It's your boy Brock here. Today we're going to be talking about what the power rule is. So as many of you watching this video, you're probably in my Cal 1 class, or maybe you're struggling with understanding the power rule. Well, as you probably just went over, the power rule is a lot easier way to take derivatives, as opposed to using that super long and boring limit definition, which by the way is very useful. Let's try and spice it up a little bit and make our lives a little bit easier. So, the power rule is an easier way to find the derivative of a function. And with these rules, there's a lot of different ones, but probably the most basic is the power rule. Let's go over what it is. Here's what the power rule says. X, some variable x to some number. And this number could be 5, it could be 30 billion, it could be 3, right? The derivative of x to some number is going to be x to that number minus 1 times that number. So, for example, on this problem, we have some number x to the fourth power. And so I look at that and define the derivative, or f prime of x. We can do a couple things. We can do the limit definition, which would be pretty long, or we can use our newfound power rule that we just came up with. So, the power rule of this function, the derivative, we're going to use the power rule, is x to the fourth power. Do you remember what the power rule says? Right. The power rule says we're going to bring this number down and multiply it. 4 times x to that same thing, but the only difference is power rule says we're going to subtract 1 from our exponent here. And as long as you can subtract 4 from 1, you can find the derivative of this. 4x to the third. Good job. And that's our derivative. The derivative of x to the fourth is simply just 4x cubed. Let's try another one. Okay, so this one looks a little more scary, but let's try and remember back to our pre-calculus or algebra 2 experience. Our function is the square root of 2x. Is there a way that we can rewrite this before we take the derivative? I think so. So if you recall, the square root of something is the same thing as that something to the 1/2 power. So in our case, the square root of something is the square root of 2x. So let's rewrite the square root of 2x in a different way. 2x to the 1/2 power. Right, perfect. And so now, we can simply just do the power rule here. And all the power rule says is we take our exponent and we multiply it to the front. So, our derivative, f prime of x, that's just notation, is equal to 1/2 times 2x, and then whatever the 1/2 minus 1 is. Well, 1/2 minus 1 is just negative 1/2, so we can just rewrite that as negative 1/2. And we're done. Perfect. Let's try one more example. Okay, this one looks kind of scary, and I promise it's not that bad. We have our function is parentheses x plus 2, in parentheses times parentheses x minus 1 in parentheses. So maybe before we do some cool calculus tricks, let's just try and break this up into a couple different smaller derivatives, right? So our function is equal to, and here I'm going to FOIL. We've done a lot of this back in Algebra 2, but let's do it one more time. So our first term times our first term is x squared. Our first term times our second term is just a negative 1. Negative x. Then our second term times our first term is going to be plus 2x, and then 2 times negative 1 is a negative 2. So, after combining like terms, our new function is x squared plus x minus 2. And now, let's do the power rule on this. Because these are all being added together or subtracted, we can do the derivatives of each of them on their own. So let's do the derivative of x squared first. The derivative of x squared is just 2x, right? With the power rule, we take our exponent, multiply by the front, and subtract by 1. And since 2 minus 1 is just 1, there's an invisible 1 there, but we typically don't write it. And now, the derivative of x. You can think of this as an invisible x to the first, like we just talked about in our other scenario. if we bring this power down, we have 1 times x to the x minus 1. And 1 minus 1 happens to be 0. And if you remember back again from Algebra 2 or Pre-Calculus, anything to the 0 power is 1. So now we're left with 1 times 1. And so the derivative of x is simply just 1. So 2x plus 1. And then finally, the derivative of 2, or in this case, negative 2, one of our rules says the derivative of a constant is 0. And so the derivative of 2, because 2 is a constant, is just 0. So we can add 0, we can subtract 0, whatever you want. But what really comes down to is the derivative of our function originally is this right here. Hope this helped. Thank you all so much for watching.